Awesome. Well, hello everyone. Thanks for joining us today. I know you guys are probably busy having fun during summer vacation, so we're glad you guys spent some time with us today to learn a little bit about electronics. So my name is Adrian Fernandez, and this is my friend and colleague Dung, and we work at Texas Instruments. And the goal here today is to teach you guys about what TI does and hopefully get you guys really excited and I guess pumped up about technology and electronics. Because who knew that we did things other than calculators? Did anyone know that? Oh, good job. So you guys did your homework maybe, so good job. So that's going to be a big part of our presentation, is to introduce you to some of the other things that TI does and how you guys can actually directly get involved. So with that, we're going to jump right in. So first and foremost, I think the story we want to tell today is that we're all makers, like me, Dung, you guys, everyone. We're all totally capable of making things. And when you think about it, here's some examples, right? We make peanut butter and jelly sandwiches. Some of us make tree houses. I never had one, but if you guys do, awesome. Super jealous. And some people make paper airplanes, right? These are all good examples of things that we make every day. But what we want to talk about is making things with electronics. And I think that sounds kind of scary because it has to do with electronic design and software coding. But we're hoping that after this presentation and after the labs today, you guys will feel empowered to actually make things with electronics. And I think that's a really exciting and powerful idea. So again, we believe that we can make stuff with electronics with the help of this little red guy here. And we're going to learn a lot about him today. So why? You know, this guy's wondering, why should we learn about electronics? So even if we can, what's so important about it? And I guess there's a couple of things. This one's probably the first one, right? We're all lazy. And I know engineers could very well be a synonym for lazy, right? Because when you think about it, engineers are really just trying to take shortcuts, right? They want to make shortcuts and design shortcuts. And that's really what an engineer does. And suddenly, what started out as laziness was actually the driving force to innovation, right? And suddenly, we have this thing called a remote control. If I gave this to someone 30 years ago, 50 years ago, or whatever, they'd think it's magic, right? I mean, I'm controlling things from afar with a push of a button. But now, this is something that we use every day without even thinking about it. And that's just one of a bajillion examples of how technology and electronics is making the world a better place. And I guess when you think about us as makers, we're really all just problem solvers. We're trying to make things easier, trying to make things faster, make things better. And by going through that process of making, it teaches us a couple of really important concepts. One concept is critical thinking, right? How do we take a really, really big problem and break it down into smaller, easier to manage chunks? Teamwork. Like one example is I'm really good at making PowerPoints, but Zung's really good at doing real engineering things. And by working together, we can really take advantage of each other's strengths. And that's something that I think making teaches us as a whole. And then lastly, how to be resourceful, right? How do we know who to ask the right questions to, or how do I use Google to find the right resources to figure something out? These are all very important concepts that making with technology can introduce to us. And then this is the kind of slide that makes you feel warm and fuzzy inside. And I think with everyone, there's a maker in all of us, right? Even the guy in the back over there. Everyone can be a maker. And when you think about makers, they're really turning the world upside down, but in a really, really good way. And we'll get to a couple of examples of that. But before we get there, we'd like to personally introduce you to something that we're calling the maker movement. And I don't know if you guys have heard of this term before, but it's the idea that anyone can take an idea and introduce it to the rest of the world. You know, software is a great example of that. I could spend a weekend coding something and immediately email it to 1,000 of my friends. And suddenly something that I created over the weekend is in front of hundreds, thousands, or millions of people immediately benefiting from something that I've created. And that's something that I think is really, really crazy to think about. One example is something that's called crowdfunding. I don't know if you guys have heard of that term before, but the idea is that if you have a really, really good idea, a really good concept, you can put your idea on the internet. And people who believe in that idea could pledge money towards it. And then suddenly you don't have to be a millionaire or a billionaire to take some really good idea and make it a reality. It's kind of power in numbers, right? If people believe in your awesome idea, they can fund to it, and suddenly you're in the 100,000, $500,000, even more than $1 million funded towards your idea, and things are suddenly becoming a reality. And here are just a couple of examples of that. And programmers are kind of a category of maker, right? A carpenter might be a maker, but he uses wood. A programmer is a maker who uses software and code and computers. And here are just a couple things to think about when it comes to programming, right? Programmers aren't programmers because they want to program. They program because they want to make stuff. It's a way to get somewhere, right? It's a means to an end. And I think the coolest thing about programming is the only thing you need to make something with software is one of these guys, right? A computer. You all have one in front of you now. Many of you have one at home, and if not, you can go to a library or your school and have access to one of these computers. And that's really the only tool you need to make a huge impact in the world, potentially with something that you've created. And again, for the first time in the history of our universe ever, for our species as human beings, is that I could share something I made with millions of people by pushing that button right there. And that's something that I think has never happened before. This is a pretty unique time that we're fortunate enough to be a part of. And here are, I guess, a couple of examples. And many of these you probably already use without even thinking about it, right? Paper maps, for example. I can pinch to zoom. I can swipe to figure out where my friend's house is. I don't have to worry about paper maps. Like, I don't know if you guys have used a paper map ever before. Maybe a show of hands, maybe like a few of you. So yeah, I mean, this is how people got around before. And they had to flip to the back and do like Battleship, where they had to go to R3 to figure out where their point of interest is. Now I can search it, right, in the little search bar there. Amazing, crazy stuff. Yellow pages. These are the big, huge yellow books that strangers leave in front of your house. And I don't know if you guys ever use them because you have tools on the web now that you can search for your favorite pizza, or you can see a picture of the food you're about to have and hear about what people thought about that food. It's a crazy idea, but that's the world we live in today. Video rental. I used to love going to video rental stores because it was kind of fun to figure out what am I going to watch tonight or what game am I going to rent and play. But now I can just stream that over the internet. So this one actually kind of makes me sad because I really like going to the video rental places. And then games, right? As fun as it was playing checkers with my grandma, I mean, I can play video games with 15 of my friends across the world now. So sorry, grandma. And the main reason why I guess Dung and I are here today is how do we get this really cool software, right, those great examples that we just talked about, out into the real world? Because when you think about it, most of that really cool software is locked up in what we call traditional hardware. It's locked up inside of these computers, and it's locked inside of these cell phones. And we really want to figure out, like, how do we get this crazy, awesome, innovative software beyond the computer on our desk and beyond the phones in our pockets. And suddenly, when you have that really cool software that was traditionally stuck inside of this big box, I can put it into everyday objects, right? I could put it inside of my phone, my refrigerator, or my teddy bear, or my watch, and suddenly these things become smarter. The same innovation that's been locked up in the computer is suddenly all around me in my everyday objects, and that's kind of a really cool thought. One idea is we could put one of these huge computers inside of these objects, right? That'll allow me to have cool software running inside of it. But that doesn't make sense because they're really big and really expensive, right? What we really need is a really tiny computer, and that's what we call a microcontroller. So a microcontroller really is this tiny computer that we're able to put inside of these everyday objects to add intelligence. And Dung and I are from the microcontroller team here at Texas Instruments. And our goal is to introduce what a microcontroller is and hopefully show you how you guys can use it to make regular things smarter. And another thing to think about and I guess realize is making in the software world, right, the programmers, they're creating something that's virtual. It's things that I can't really touch. And I have to use traditional hardware like a computer or a cell phone. And really what that means is that I only have a couple of our sort of human senses to interact with this innovative software. It's through sight through a computer monitor or sound through my computer speakers. With the advent of touch phones and touch screens, maybe I get touch a little bit, so I get 2.5 senses I get to play with, right, with these really cool software. But that's where the microcontroller becomes really interesting, because by integrating it into my teddy bear, for example, suddenly I have a physical product that's interactive. So I couldn't really hug my computer, but I could hug a teddy bear. And what that means is that I get all of the senses at my fingertips, right, with something that I've created. I could hear things that my teddy bear might say. I probably wouldn't taste the teddy bear. You could if you wanted to, but it's probably a bad idea. You can see it, you can touch it, so suddenly it's a more engaging, interactive final product, which I think is really, really cool about embedding microcontrollers into these products. And another really cool concept is that by making, it really enforces other disciplines or other subjects. You guys probably know a whole lot about these regular subjects or more traditional subjects, but with making things with electronics, suddenly you can make some of these things even cooler. I could embed a microcontroller into this catapult to figure out how far it's going to go, or how my change in angle might affect the distance or the height of the projectile I'm launching. We can also combine a lot of these subjects together to make more interesting applications. One example is running technology from a potato. I don't know why you would want to do that, but you can, and that's really exciting and a really cool thought. And by tying all these things together, that's really what engineering is, right? It's solving problems and pulling from all of these different disciplines to create a final product and solve a real problem. So I'm going to hand it off to Dung here, and he's going to talk a little bit about why some of these cool things haven't quite happened yet. I think we're really, really close, but there's a few things that are getting in the way, and Zung's going to talk a little bit about that.
All right. Thank you, Adrian. So far, Adrian has already shown you an amazing picture of all the things you can do with software and hardware, right? But why isn't your fridge tweeting to you every day when it's running out of milk? Or why isn't your curtain just closing or opening the blinds whenever it's sunny outside? Why is it not happening soon enough, or why can't you see it outside? It's because there's still quite a few problems or a few obstacles that we need to get over to get there. The first problem is that hardware or microcontroller in general is hard. It's not an easy thing to do. So this is where Adrian and I had to go to learn all about microcontroller. You go to college, you learn all these crazy equations and theories and everything, and you had to spend about 4 to 6 years to learn all this stuff. If you go to a career fair and say, hey, I want to become an engineer, and I have to go to sit through 6 years of this stuff to make something cool, and that's pretty discouraging, right? So you gotta go through years of formal education, and after that you have to go into work and design this crazy circuit board, learning how to use all this complex tools. You gotta learn this on the job. So it is not easy to start making stuff. The second problem is that not only that it is hard, it's also really hard to find information about hardware online. You might go online. Even in the classroom today, there's not a whole lot of engineering curriculums. Is any of you going to be taking engineering courses in the next year in high school? Probably not, right? Because there's not a whole lot of engineering curriculum in high school. Usually we have to go to college to do this. So how can teenagers start making stuff with hardware today? Maybe online, right? Online is always a good resource, but online is also huge. The internet is a huge, vast amount of knowledge, and you don't always know where to find the right information. So you might get lost trying to find the right information. The third problem is that hardware is also really expensive. These tools cost a lot of money because they were designed for other engineers, other companies who have a lot of budget to spend and buying all this expensive equipment. So this is an example of a engineer's workbench. So all of these crazy equipments, analyzer, they cost hundreds or tens of thousands of dollars. So again, students or teenagers, how can we start making? We can't afford any of this stuff. So we have 3 problems today. Hardware is really hard. You can't find the right information online to even start learning. And then you can't even afford the tools. And our fridge is still not tweeting to us yet. So how can we solve this? We can all solve all 3 of the problems with the LaunchPad because we believe that tech instruments believe that with LaunchPad you can start making with both hardware and software much simpler and much easier. And anybody, starting with kids, teenagers, students, anybody can start making today. And how do we do that? The first solution is that hardware can now be made easy. If you think of before, when you want to design a hardware product, it takes a lot of work, it takes a lot of thinking, and you got to go through years of school and learning to figure out how do I design hardware, how do I interact with electronics. what we can do here is actually, as an example, right? If you want to look at a product as a whole, you might, a good analogy is looking at a puzzle. If somebody gives you 1,000 piece puzzle and asks you, hey, why don't you put this puzzle together over a weekend? That's really tough. That's almost impossible, because 1,000 pieces, that it's going to take a long time to learn and figure out how to piece all these pieces together. Now, what if we just give you combine these pieces and make it into big chunks, and now give you just 5 big pieces? Do you think you can put this puzzle together? It's a lot easier, right? So the solution to all of this hardware problem is that we will make big modules. We turn big complex problems into much simpler problems by giving you big components, and that's what the LaunchPad can help you with. So with the LaunchPad, we provide several components that you can add onto the LaunchPad. Let's say you want to turn on lights, let's say you want to display some text, you can just get the display module or the lights module or some kind of sensor module, and you plug it together and it just works out of the box. So you don't have to design this complex board, you don't have to learn about electronics. You can still start plugging things together and start experimenting with it and learning with it. So these are a few of the examples of the hardware or the booster packs or the components that you can play around with the LaunchPad. Let's say you want to add a light matrix, or you want to add wireless communication to your LaunchPad or to your cool toy. All you have to do is buy these components. They are pretty affordable. Plug them in together, and then you can get the whole experiment going really fast and really quickly. For the second problem that we had earlier was that there's not a whole lot of information online, right? The good news is if you know where to find the right information, there's a whole lot of good information online, and these are the places that we highly recommend you going to. These are the places what we call online communities, where people just like you and I, if we have a problem or we have the answer, we go in there and ask the questions and share the answers, and not just going beyond just answers and questions. If you have a cool project, if you have a cool idea, you can go online and share that idea with each other. You can say, hey, guess what? Over the weekend I made this cool toy, and this is how I did it, step ABC. Check it out, guys. And other members can go in and say, oh yeah, that's a really good idea. I want to take that and I want to make my own version of that. I want to add step 4 to it, and I want to share back to the community. So by joining this community, by learning from this community, you can really learn how to do hardware really fast and really easily. The third problem, we also have the solution for the third problem, which is microcontroller tools. Hardware is so expensive these days. That is no longer true. We can actually make these tools a lot more affordable, and that's where the LaunchPad comes about. It only costs $10. That's probably like 2 lunches for us, right? 2 lunches will get us a complete microcontroller development kit. So let's take a quick look at the LaunchPad, which each one of you will have and get to play with today. Is on your desk. So what's on the LaunchPad? What makes it so cool and affordable? So in the middle of the LaunchPad is the most important piece. It is the brain of the whole LaunchPad, and that is what we call the microcontroller. What's so cool about the LaunchPad is that you don't need anything else to start programming and start learning with LaunchPad, with microcontroller. So traditionally, you buy this, this board, some board, and then you will also have to buy expensive tools to connect this board to the PC or to your laptop in order to program it or to play with it. And those programming tools could cost anywhere from hundreds to thousands of dollars. And guess what? All of that is now integrated on board, and it's right here. And the whole thing costs you $10. So it's a lot cheaper, it's a lot more affordable now for anybody, for students like you and I, to just purchase it and play with it. Another thing that is really cool about the LaunchPad is, with the LaunchPad, there are several ways to interact with it through this thing we call pins, or the legs. So if you see all of these legs on the microcontroller, these are the way that the microcontroller interact with the outside world. And through those pins, as we call it, you can tell the microcontroller to turn on the light, turn off the light, receive a button, or send a message wirelessly to somewhere else. So these are the ways that we interact with the outside world using a microcontroller. And we, of course, the LaunchPad comes with a couple of lights that we call LEDs, as well as buttons, so you can already interact with the LaunchPad. And the LaunchPad concept is really simple if you think about it, and it is a really good way to look at it if you want to start out doing something cool with the LaunchPad. Think of the LaunchPad as a brain, and this brain is really simple. All it does is it receives some kind of input, and it processes that input, and it tells you what to do based on that input. So if something happens, I will need to do something else. So for example, if it's really hot outside, maybe I should turn on the light, huh? Or maybe I should turn on the fan to kind of blow cool the air off. Or if it's getting really hot, maybe I should turn on the buzzer and let everybody know it's getting too hot in here. So by adding all this tiny piece of brain into these everyday objects, you can make a lot smarter. For example, if you want to turn your teddy bear into something really cool, you can make it so that if the teddy bear is hugged, maybe it sings a song back to you. Or if it's really dark outside, you can just turn on the light. So microcontroller with a tiny piece of brain can make everyday object a lot smarter. And the key concept here is that we can all start making with just $10. That's the price of a LaunchPad. And the software is completely free. And we will use this software today to program the LaunchPad, and it is called Energia. It's already on your laptop. And here are just a few examples of what people have done with the LaunchPad. So most of these are actually students, 18, 19-year-old students who came to TI or just using the LaunchPad over the internet and sharing what they have done. For example, some guy made a rocket launcher, a tracking rocket launcher with a LaunchPad. Or some other person made a line following robot where the LaunchPad just detects a white line and kind of follows it. And then some other folks are pretty savvy with the Internet of Things, and they made a Twitter out of LaunchPad. So if you receive a new Twitter message, it will display on the LaunchPad. And these are all just weekends or just hobbyist projects that anybody can do with the LaunchPad. So most importantly, we believe that with a LaunchPad, anybody can start learning about microcontrollers, starting with you today. So let's get started with the labs. We will go through 3 labs today. We will start with simple. Project number 1 is where you will do the most fundamental project of any microcontroller engineer would ever do, and that is to blink the light on and off. A second project, we will go to using music and using other sensors on the LaunchPad to make something even cooler. In the last project, we will work with something that's like a very everyday toy. We will make a magic 8-ball out of the LaunchPad, and then based on that, we can decide on what we're going to have for lunch. All right, so Adrian will start off with the first project.
Cool, thanks, Dung. Yeah, so before we jump to the first project, we've got some boxes and goodies in front of you. So the one inside of the black box, that's the LaunchPad. So you guys can go ahead and tear into it and pull the LaunchPad out. And inside of that box should be a red rectangle, and that's what we call the LaunchPad. That is our microcontroller development tool that we're going to use to do some of these projects here. So I'll give you guys a second to open it. Okay. Sweet. All right, I see lights everywhere, so I think we're in good shape. Awesome. So that means our LaunchPad is now connected to the computer. It's receiving power, and our LaunchPad is actually preloaded with some demo code. So there's already some code inside of the LaunchPad that tells it what to do when it receives power. So we're actually going to program over that example firmware or example software, and that's what we're going to do by blinking an LED. Which is something that we call a light. I don't know if you guys are familiar with that term. So LED stands for light emitting diode. So it's a lot of big words, but really what it means is it's a simple light. And that's going to be what we use to have the LaunchPad communicate back to us by blinking that light at different speeds and different patterns. So we already did this step. We connected the LaunchPad over USB to the PC. So good job. Step number 1 complete. The next step is we're going to move on to the computer now, and we're going to launch the software tool that Dung introduced called Energia. Energia has a little icon here, so if you can find that on your desktop, just double-click it, and that will open up the tool. And that's what we're going to use to create code and create software that we're going to put inside of the LaunchPad brain. So once you open up the tool, you should get a window that kind of looks like this. And the first step is to follow this, this directory or this path here. So if you click on Tools, Board, you'll have the option to select LaunchPad with this funny name here, MSP430 G2553. And that is the part number for the microcontroller brain that we're using. So we're basically just telling our tool on the computer what kind of microcontroller brain we're programming. So if you just follow that path here, and you can see a little screenshot, that'll configure your tool so that it knows what it's doing. Awesome. So Project Blinky. So again, LED stands for light emitting diode, and that's what we're going to use to blink the light. The LaunchPad itself actually has two of these LEDs. There's a red one and a green one, and they're down here on the bottom of the board. So you've got a red one and a red one here and a green one here. So they're really, really small, but once we program it, we're actually going to see that light blinking in different patterns. The goal for this specific example is we want to blink that LED 10 times, and 10 times only. So that's going to be our first project to basically show that Energia, the software tool, can interface with the microcontroller and do exactly what it is we want to do. So to do that, Energia comes with a lot of example code. So there's a lot of examples already preloaded inside of the tool. And what that means is that you don't have to write everything from scratch. You can use one of these examples, and if it's exactly what you want, then perfect. You don't have to do anything. You can just use what already exists. Or if it's really close to what you want, you can actually use that code example and modify it a little bit to create whatever it is you're trying to create. So the whole idea here is reuse and not having to reinvent the wheel every single time. If you can find a code example that's 80% of what you want, you should start from there. And I think that's a really important part of making things and actually being an engineer is making sure that you're aware of what's already available for you. So to find this example, just follow these steps here. If you just go to File, Examples, 0.educationalbp, Chapter 5, and Project 3 LED Blink. So it's kind of a long path. But if you follow that, you should find the example code that we're going to be using today. Cool. So I guess before we jump into this project and look at the code, let's think about what we have to do. So we want to blink the light, right? And as Dung mentioned, the microcontroller brain has these little pins or legs, and that's what reaches out of the microcontroller. And those pins is what interacts with the external world. In this case, it's talking to the LED. So if you were to draw a simple picture of kind of what that looks like, it'll basically be this little microcontroller brain. Just looks like a rectangle, right? Nothing fancy. And you can see it right there in front of you in the middle of your LaunchPad. And it has these little silver connectors on the side of it. And it looks kind of like a bug, kind of like a centipede. Right? And there's 10 on each side. And each of those legs or pins are connected to different components of the LaunchPad. Some are connected to the lights. Some are connected to the buttons. Some are just exposed, which allows you to connect external components to the LaunchPad. And that's how some of the booster packs, those modules that Dung talked about, actually plug onto the LaunchPad, is by connecting to these different legs. And one of those legs is actually connected to the LED that we want to blink. So the first step that we'll have to do is actually tell the LaunchPad where that LED is, so it knows which leg to use. And that's going to be the first thing that we're going to do inside of our code. So the first step is, again, setting the pin as an output. So we say, hey, LED pin, you're going to be an output. You're going to be outputting current through that pin. And that's what's going to cause that LED light to turn on. So that's the first step that we'll have to do in software. Secondly, we're going to do what we call a loop. And a loop is something that we're going to repeat over and over again. And in this case, since we want the LED to blink only 10 times, we're just going to turn it on and off 10 times to cause the blinking pattern. So I just said a lot of things, but once we look at the code, we'll see exactly what we're talking about. So if you guys take a look at the code today, it should be right there in front of you now that you've opened up that example. That's exactly what's happening. And the code inside of there's some text that's green in color. And that green text is what we call comments. And comments are meant for you as the user or the student or the programmer. And those green comments allow you to understand what's happening inside of the code. So you can take a look at that to kind of understand what's happening at each line. So now that we kind of have a better understanding of what's happening, we can actually click this little button here that looks like an arrow. And that's going to download that code that's inside of your software tool into the microcontroller brain. And then suddenly the microcontroller is going to do exactly what that program told it to. So go ahead and click that button, and you should see a couple of things happening on the computer. But by the end of it, your LaunchPad will have the new firmware, the new software that you downloaded to the microcontroller. And then keep an eye on the LaunchPad, because once you do that, the code will immediately start running. And make sure that that green LED blinks only 10 times, because that's what we told it to do. Is it blinking? Let's see, I see some head nodding. Did you keep count? Yeah, how many times? 10, yes. Awesome. Cool, how's yours going here, buddy? Cool, I think it's this guy right here. So that should take the code from the computer and shoot it through the USB cable into the microcontroller brain. Congratulations, you guys are one step closer to being an engineer. That's awesome. So we just blinked that green LED 10 times. So that's pretty cool, right? I mean, it's not quite as cool as a teddy bear hugging you, but this is one step closer in that direction. So now that we have this code example, there's a couple of things that we can change. And this is a good sort of a project to introduce a concept of reuse, right? With this existing code example, the green LED is blinking 10 times. What if I want the red LED to blink instead? What do I have to change? Or what if I want it to blink faster or slower? What are some of the things I have to change inside of the code to make that happen? So I'm going to challenge you guys to actually take a look at that code example that's in front of you and try to figure out what things you can change to either make the LED blink faster or maybe make the red LED blink instead of the green one. And by going through the process of trial and error, a lot of the times will lead to innovation. And I think that's something that we want to challenge you guys here to do today. So go ahead, and we'll give you a few minutes to dive into the code. And again, try to change some of these parameters here. You know, maybe instead of blinking 10 times, make it blink 3 times or 100 times. And try to keep count. So we'll let you guys do that, and we'll walk around and try to help you here. Cool. What are you trying to do here?
Well, I already made it blink 5 times.
Oh, man.
Try to change the speed. Yeah.
Speed racer. Good job. All right. 578. Cool. That's a lot of blinking.
What do you think that's going to be?
It's going to make it blink really slow.
Yeah.
Awesome. Cool. You guys did it.
A lot.
So it looks like the first thing you guys tried to do was change how many times it blinked. And you guys went from 10, someone went to like 500 something. So pretty cool. Cool. Well, I think that was it for Project Blinky. So I think we were able to blink one light. We blinked both lights. I think some of you guys had them alternating. You guys were able to change the speed of the LED. And I think we learned a couple of things, right? We learned about how the microcontroller pins or the legs talk to external components or external things like the light. We also learned about loops and how things repeat over and over again. And I think we also learned about how to reuse code examples, right? We didn't really have to write everything from scratch. We were able to take an existing code example and actually modify it to whatever it is we wanted to do, which I think is a pretty cool concept. So with that, we're going to jump to project number 2, and I'm going to hand it off to Dung here. And this one's one of my favorite projects, so get excited.
I'm so happy to do this one. Okay, so today we're not just learning about texture instruments, we're not just learning about LaunchPad, but we will make ourselves some musical instruments. And in order to make music, right, we'll need a little help from a friend of the LaunchPad, and that is the Educational BoosterPack. So we talked about earlier what a BoosterPack is. A BoosterPack is something, it's like a little additional tools that you can add onto your LaunchPad to make it more powerful, right? You can add things like display or light or sensor. So the Educational BoosterPack that each one of you also has on your desk has a lot of components and cool stuff that can that the LaunchPad can control and do cool stuff with it. We have a display screen up here. We have a buzzer that we will use in this project, and we have a bunch of other cool components that we will use in the next couple of projects. For this project, we will use 2 things. So feel free to take it out of the box, the white box, and you might be able to notice on the board, on that BoosterPack, there are 2 components that we will be using for this lab. And the first one is a potentiometer, and that's a little thin wheel that allows you to kind of scroll up and down, just like a volume knob. On the other side, we have a buzzer. So the buzzer is something that makes a sound. It can actually make any kind of sound at any frequency. So the microcontroller can tell it, hey, make me a pitch at 400 hertz, and the buzzer will make a sound at exactly 400 hertz. So what we will do today is that we will read the input from the potentiometer, and when you scroll the wheel, you're actually changing it up or down or lower or higher. And based on that scrolling wheel motion, the LaunchPad can read that in and tell the buzzer to make a pitch or a sound based on your input. And based on that, we can make our own musical instrument. So just very quick thing, earlier Adrian mentioned the microcontroller looks like the chip with about 20 legs coming out on both sides. So what is also important is that we need to find out what pins or what legs are connected to these components. So this map, it just gives you a quick overview of what the components, or which pins the components are connected to. So our potentiometer is connected to pin number 5, or it is also known as A3. And you will see this again in the code later in our sketch. And this is how you know that Energia is telling the microcontroller, hey, read the input from channel A3. On the other side, for the output side, we have the buzzer connected to pin number 19. And that is the pin that you will also see in the code in the sketch, where the microcontroller is told that, hey, make a sound on pin number 19. All right, so the only hardware change that we have to do is make sure that jumper is in the right position. So the jumper or the header is this little black thingy that is now connected to a few exposed pins on top of the booster pack. So what you want to do there is to make sure that the black jumper is properly on top, and then there should be 2 pins by themselves, and then there should be all you have to do is just move the top jumper or the top black header, this guy right here, unplug it, and then plug it onto the top position. So what it does is, as we will learn later on, these 3 pins are all connected to our potentiometer, but it's also connected to another component that we will be using later on. So for this lab, we want to connect it to a potentiometer, and that's why we have it put it on top. For another lab, we might have to put it on the bottom. So as similar to before, go ahead and try to find our sketch. So just follow this trail, file, examples, 0 educational BP, and now we're going to chapter 9 and project number 19. Musical instruments. There are a lot of musical examples in that chapter, so be careful. Make sure to select the musical instrument sketch. Is everybody there? Now you should see yet another new window open up with new code, right? So let's go through the code really quickly. You see that this code is quite long, but as a matter of fact, most of the code is actually just green lines, right? As Adrian mentioned before, those are just comments. Those are just what try to explain and helps you, reminds you of what's going on. So in a reality, the main code, there are only 3 lines of code that you really have to look into it to figure out what's going on. And that's all you need to read the information from the potentiometer, process it, and then make music out of it. So let's go line by line. So this is the first line where you can read out. You are pointing analog read from the channel number A3, and you read that value and you store it into sensor reading. So what does it mean? What it means is that by scrolling that little wheel, you're actually changing the value on that sensor, and that value is being read into the microcontroller brain through the analog read function, and the result is stored inside sensor reading. So now sensor reading is the value or the guide that we know what the value was on the potentiometer. Second line, this is where the brain is at work. This is where the brain processes this information inside sensor reading and determines what kind of pitch should I make out of this input. And that's where the magic happens. And as a result, it produces this pitch. And this pitch is actually the frequency of the sound of the note that it's going to tell the buzzer to make. And it's doing that in the last line. Really simple. All it does is make a tone on pin number 19 of the frequency of stored in this pitch, and make that tone last for 100 milliseconds. So really simple, right? 3 lines and 3 simple functions, and now you can make your own instrument. So let's give it a try, shall we? At this point, you can click on that upload button again, and let's see if we can make some music.
Oh, let's make sure the booster packs are plugged into the LaunchPad as well. It just stacks on top. So remember, these are plug-in modules. So just make sure all of the pins are connected. And if you just plug it in,
if you can
there you go.
plug in the other way around. Yes,
right on
that's
top.
right.
Rotate it. If you rotate
Yep, you have it right. Just push it all the way
just like
down.
that, and then just plug it right in. So be sure to try to turn it to see what happens on the sound side. There you go. Oh, it's this guy right here.
All right, so if you want to stop the music, what we can do is just unplug the LaunchPad from the USB cable. You can resume this at home at any time. So let's pause with the music for a while. All right. Oh, I feel peace, so much peace. So what did we learn in this really short lab? I mean, we learned a lot of concepts, right? We actually, first and foremost, most importantly, we learned how to make music. And this is actually how a lot of musical instruments are made, with just maybe a little bit more intelligence in there. But the key concept is the same, right? You have some input. It could be like a keyboard, and you just press it on the keys. And the brain inside the keyboard controller will decipher that. It's like, oh, you press on this C4 note, so I need to make this frequency of this, 400 hertz, for example. And that's how tones are being made. We learned about inputs and outputs. And we have already used input and outputs for a couple of times already, but the key concept of any microcontroller application or anything that you will ever make is there's input and there's output. As long as you identify what are your inputs, and you figure out how to read that input in, and you figure out how to process the input, and then the last step is figure out what are your outputs, what are the things that you want to express to the world, whether it's light, whether it's display, whether it's messages or wireless. Once you figure out the inputs and outputs, you can kind of create any application you want. And the last but not least, we learned a couple of functions. These will be helpful later on if you want to do your own projects. So these are the analog read, which allows you to read in any analog signal, and tone, which allows you to make music. So there are a few other musical examples that you can do. Feel free to give it a try. If you know the notes to the song, right, you can make your own song. So instead of using the scroll wheel to figure out what notes you're and turn it into a musical instrument, you can actually tell the microcontroller to play a song. So by putting all the notes in, you can actually make a tune like birthday music or like a Star Wars theme. So give it a try. And so all of these examples are also already in Energia. You just have to follow the same path again and go to chapter 9. And there are a few examples of other musical projects that you can open up. All right, so our challenge to you out of this exercise is when you get home, try to find your favorite tune, try to find your favorite piece of music, and then find all the notes and try to compile that list of notes and put it into LaunchPad and make your own song. How cool would that be? All right, so let's pause with the music and move on to the next project. So Adrian will guide you through the next, and this one is even more fun, and you can make your own game out of this.
Awesome. So we're moving on to project number 3. We're going to create a magic 8-ball. I don't know if you guys still play with that, but it's basically this round black object that you shake whenever you have a question, and it'll give you a random answer, right? Yes, no, maybe so. So we're actually going to recreate that with our LaunchPad with the help of the Educational BoosterPack plugin module. Here are the sort of ingredients for this example, right? We've got the LaunchPad brain. It's going to work with the booster pack, and we're going to combine those two things together to create a magic 8-ball. And previously, right, we created a musical instrument, and that musical instrument was using an input, which was the little scroll wheel, the knob, and doing a little bit of thinking in the microcontroller brain, and then outputting sound through the buzzer. So we were going to take that same idea of inputs and outputs with our musical instrument here. What we're going to do is we're going to use something called an accelerometer. So that's what this little tiny black rectangle is on your educational booster pack. And an accelerometer is something that you might see in a video game controller. It's in a lot of cell phones today. That's how you kind of play games, by moving your phone around. It's because they have something called an accelerometer inside. And we have one here on the educational booster pack. So we can actually use that accelerometer, which detects motion and communicates that motion information to the microcontroller brain. And based on that type of input that we're getting from the accelerometer, the microcontroller brain can say, oh, I'm being shaken, or I'm being tilted in one direction. And with that information, we can do whatever we want with it, right? Dung mentioned one idea, I could use that accelerometer data to change the frequency of my music. So instead of turning the wheel, maybe I'm making a musical instrument whenever I do jumping jacks or something. So that's one example. So we're going to use the accelerometer today to detect when the LaunchPad is being shaken, just like the regular Magic 8-ball. And then lastly, we're going to output yes, no, or maybe so to the display, the liquid crystal display, or the LCD. And basically, we're going to have that same input, do a little bit of thinking. When shaken, I'm going to output a random display to the LCD module. So these are kind of the main components for this specific example or project. And then also, just like what Dung talked about earlier in the last lab, these different inputs and outputs are connected to different legs of the microcontroller. The accelerometer, for example, is connected to pin number 2, 5, and 6. And that's how the code knows which pins do I need to be looking at and thinking about whenever I'm doing my example project. Similarly, on the LCD side, this also has a couple of connections to the microcontroller. And this sort of map just tells you where these things are connected, so that when you go to your code, you know exactly where things are connected. So it's a pretty helpful map to have. So again, first thing we're going to do, I think most of you already have your educational booster pack plugged in. But this time we're going to have to move this little black jumper again. So this little black connector, we're going to move to, I think it's just that top one, we're going to move it down a notch to its original position. And this is basically going to tell the educational booster pack that I don't want to talk to the little knob anymore, I want to talk to the accelerometer. So we're basically just choosing a different form of input by moving that connector. So yeah, perfect. Looking good.
Actually, both of them.
Looking good as well. Awesome, so we're in good shape. So just like before, we're going to go to Energia, our little software tool, and we're going to follow this trail to a new example project called Magic 8-Ball, and you can get there by following this path. And that'll open up the code that'll tell the LaunchPad to become a Magic 8-Ball now, instead of a musical instrument. Awesome. So once you guys have that, you can plug your LaunchPad into the computer and hit the play button, or that download button with the arrow. So that should silence the music and change the LaunchPad from a musical instrument to a Magic 8-Ball. Cool. And before we start shaking our LaunchPad, let's think about what we have to do. The first thing we have to do is tell the LaunchPad that, hey, you have a display connected to you, and that's happening in the code. That's one of the first things we do. Then we say an intro text, the intro message on the display. We're going to say, hey, welcome to the Magic LaunchPad, or something along those lines. And then we're going to get to the real sort of intelligence or the smartness of this application. We're going to read the accelerometer. And the accelerometer has what we call 3 axes or axi. There's X, Y, and Z, right? So there's 3 directions of motion that our accelerometer can detect. And we're going to do a lot of math, actually. Or actually, we're not doing much math. The LaunchPad will do some math. That's going to combine all of these different motions of direction and figure out whether or not our LaunchPad is being shaken. So that's where we can actually use some physics. So I don't know if you guys are familiar with the resultant vector, multiplying different angles in different directions to figure out where the true sort of final direction is. And our LaunchPad can actually do that in the code using some math. And if the specific output, or if that output vector is exceeding a particular strength, that's how we know that our LaunchPad is actually being shaken. And if so, if it is being shaken to a certain degree or to a certain level, that's how we know that, hey, I should probably display a random message now. And that's all happening inside of the code in front of you today. So the first thing that we'll go ahead and do is we're going to hit the arrow button. I think you guys already did that. And before you can do it, just unplug and replug in your LaunchPad, and I think that should get it going. Cool. Does everyone say shake the magic LaunchPad on their display? So that's the first message that our example sketch tells the LaunchPad to do, is say, hey, shake the magic LaunchPad. And if you shake it, it'll give you a random answer, yes, no, or maybe. So if you can think about a question you want to ask it, like, will I work at TI maybe in the future? You can try to shake it. Hopefully it says yes. So that's it. I mean, that's a magic 8-ball. Just like that, we were able to change our LaunchPad from a musical instrument to a different interactive project. So now that we have this code example, I'm going to challenge you guys to go into the code and actually try to figure out where you have to change it, so that instead of saying yes, no, maybe it says, what kind of lunch am I going to have today? Pizza, spaghetti, or ice cream? And if you actually find that place in the code, try to modify it and see if it works. And then suddenly, instead of a magic 8-ball, it's a lunch selector.
Did you get potatoes?
And we've done this lab a couple of times, and sometimes people put ice cream for all the choices, so no matter what, it always says ice cream. It's a good idea. Or spaghetti tacos, if that's what you want. Ice cream, pizza, cool. So I'll give you a little hint here. So this random command, so this is going to return a random number between 0, 1, 2. So based on the random number that gets generated, it's going to store it into result. And then this function here called switch is going to take that number result. If it was a 0, it'll say potatoes. If it was a 2, it'll say pizza. If it was 3, then it'll say ice cream. So what we have to do is actually change that number 3 to a 4.
Okay.
And then that'll tell the result that, hey, I can return values 0, 1, 2, and 3 now instead of just 0, 1, and 2. So yeah, if you just change that to 4 and then change that number to 4 down here. Oh no, I think you're fine actually. Yeah, good job. Yeah, that's the only thing you have to change. Good job.
Okay.
Nice. So we need.
See already?
Yeah, I think so. Yeah, I guess I'll close this one out. Cool, guys. Awesome. So you just created a magic 8-ball. It went from yes, no, maybe so. It became a lunch chooser. Some of you guys did, what sports should I play next? Awesome stuff. So yeah, really, really cool. So this was another example of inputs and outputs and how you could take an existing code example to create something a little bit more unique for your specific application or use case.
We have learned a little bit about LaunchPad today. We have also gone through 3 labs, right, and figuring out what simple things and really easy things that you can immediately do with LaunchPad. So where do you go from here? So you can actually learn a whole lot about LaunchPad, and if you take the LaunchPad home, we encourage you to do a lot more fun stuff with the LaunchPad. And where do you find the information? You can go online. There's a wonderful website out there called 430.com, and there are about 20,000 members, students, young kids, or even like engineers who just go in there, contribute, and share information and share ideas or projects. So if you have any questions or if you have any ideas or projects in mind, go in there, find out, and you can get started with your LaunchPad like that. TI.com is also a good website. You can go in there and find information about the different LaunchPads, different booster packs, what are the software that you can use with your LaunchPad. So yeah, go online and download all this stuff, and you can immediately start making with the LaunchPad. Last but not least, the software we're using today is called Energia, and it's completely free, and you can download it from energia.nu. And if you have a computer, you have a Mac or Linux, you can download the version for any of the computers you have at home. And we also have a book. So if you guys are readers, definitely check out the book. The book actually walks through all the content that you saw today, all the projects, all the lessons that we gave you today. That's all part of the book, so definitely check it out. And with that, thank you for coming today. We hope that you learned a little bit about LaunchPad. And hopefully you had a little bit of fun making cool projects with the LaunchPad and the booster pack today. Most importantly, we would like you to get out of here just a little bit inspired, and hopefully when you get home, you'll be just excited and get the LaunchPad and make something cool with it. And if you do, let us know and share with us. Send us an email or just share it with the world. Thank you.